In this video, we'll discuss mini-batch gradient descent. First, we'll talk about mini-batch gradient descent, and then we'll talk about mini-batch gradient descent in PyTorch. In mini-batch gradient descent, we start off with a batch size. Let's do an example where the batch size is 2. We'll use the first 2 samples to approximate our total loss or cost function. Then we use the second 2 samples to approximate our total loss or total cost function. Let's use the different colors to represent the different loss functions obtained through each iteration of mini-batch gradient descent. Just a little note, when our batch size equals 1, we're actually doing stochastic gradient descent. So let's start off with a batch size of 2. For the first iteration, we use the first 2 samples, and we differentiate our cost function. Then repeat it for the second iteration. We use the second 2 samples, and then we do it for the third iteration, where we use the last 2 samples. Notice, to go through one epoch of data, it took us 3 iterations. We repeat the process for the second epoch, and it takes a total of 3 iterations to go through the data. Let's see what happens when we choose a batch size of 3. To go through one epoch, it only took 2 iterations. For the second epoch, it also takes 2 iterations. You can calculate the number of iterations required to go through one epoch by simply dividing the size of your trading set by the batch size. Let's keep track of the batch size here and the number of iterations over here, and go through a couple of examples. If we choose a batch size of 1, it'll take 6 iterations to go through all the data. Let's keep count. Try with a batch size of 2. Plugging the numbers into our equation, we get 3. So we're on the first iteration, we proceed to the second iteration, and then we get to the third iteration. Finally, let's try a batch size of 3. The result should be 2. We're on the first iteration, we proceed to the second iteration. And that's all it takes. Now let's discuss mini-batch gradient descent in PyTorch. Let's choose a batch size of 4. Nothing has changed when we construct our dataset class. We create a dataset object. When we create a data loader object, in the constructor, for the parameter batch size, we set it equal to 4. Let's run through one epoch of batch gradient descent. The first nested loop will run through the several iterations. In this case, our test size is 48, our batch size is 4, so it should take 12 iterations to run through the data once. Perform the first iteration, second iteration, until we get to the 12th iteration. Our data space changes, and we approach the minimum of the total loss or cost surface. Batch size can affect the performance of your model. In this example, a batch size of 5 took less time to converge to minimum, i.e., less number of iterations to reach a smaller total loss or cost.